Okay, now we will measure the divisions vertically. 1 2 3 3.8 divisions. Now 3.8 divisions multiply by 0.5. So 3.8 multiply by 0.5, which is equal to 1.9, which is equal to 1.9. So peak to peak voltage is 1.9 volt. Now to get the peak voltage, what you will do, you will divide it by 2. So 1.9 divided by 2, which is equal to 0.95, and multiply this value by 0.707. So you will get the value, that is 0.67. Okay, so this is the voltage from the CRO. Now to measure the voltage on multimeter, you have to select the range, that is 20 volt AC, because you are measuring the AC voltage. Now from the multimeter you are getting 0.66 volt. To get the percentage error, you have to do the calculation, that is percentage error is equal to V, that is the voltage from voltmeter minus voltage from CRO divided by voltage from CRO. That means the CRO voltage we are taking, that is as a standard, and we are calibrating this multimeter against the CRO. So from that you can calculate the percentage error. So one more reading I will show. Now I am increasing the voltage using the knob on the function generator. Okay. So now you can see this signal which is going out of the screen. So what I will do, I will increase the volt per division. Volt per division. And again the same procedure you have to follow, that is measure the number of divisions. So I am touching it to the some reference line, 1 2 3 4 5. So I am getting the 5 divisions multiply by 1 volt per division, so it is 1. So you will get peak to peak voltage, that is the 5 VPP. So peak voltage is 5 divided by 2. So 5 divided by 2, so it is 2.5 volt. Now multiply this 2.5 by 0.707. So you will get the voltage, that is around 1.77. So the voltage measured using the CRO, that is 1.77 volt, and on the multimeter I am getting the voltage, that is 1.75. So using the percentage error formula, you can calculate the percentage error. So these are the couple of readings. Now I will go a little bit faster and show you more readings. So I am increasing the voltage from here. Okay. Now you can see the number of divisions, 1 2 3 4 5 6, that is 6.8 into 1, that is 1 volt per division. So you will get the peak voltage, that is the 6.8 volt. So divided by 2, you will get the peak voltage, that is the 3.4 volt, and multiply this by 0.707. So you will get the actual voltage, that is the 2.40. So this is the voltage. This is the voltage from the CRO, and from multimeter I am getting the voltage, that is around 2.37. So using these two values, 2.40 as a standard and 2.37 from the multimeter, you can calculate the percentage error. So I am increasing the voltage again. Now I have to shift the volt per division. Okay, follow the same procedure, measure the divisions, 1 2 3 4 5, that is around 5.6. okay, multiply by 2 volt per division, so it will become 5.6 into 2, which is equal to 11.2, again divided by 2 to get the peak voltage. So it will be again 5.6, multiply this 5.6 by 0.707. So you will get the voltage that is around 3.96. 3.96, that is the voltage from the CRO, and from the digital multimeter 3.98. So one more reading, I will increase the voltage and then shift it little bit so that I can measure the divisions accurately. So now you can see 1, 2, 3, 4, 5, 6, 7, it is 7.6. So 7.6 into 2, which is equal to 15.2, that is peak to peak voltage, divided by 2. So you will get the peak voltage, that is 7.6, and then multiply this voltage 7.6 by 0.707. So you will get the value, that is the 5.37 volt. Those 5.37, it is from the CRO, and here you are getting around 5.38. That is using the digital voltmeter or digital multimeter. So we have noted down the 5 values for the different voltage. To understand how you can use the knob, that is the sensitivity knob, volt per division, to measure the accurate voltage from the CRO. And we are trying to calibrate this multimeter against the CRO. We are considering this as a standard value, and this is the measured value. So the percentage error you can calculate, that is the voltage from voltmeter minus voltage from the CRO divided by voltage from the CRO into 100. Now I have to measure the frequency. The measurement of voltage, that part is over. Now we have to measure the frequency. So I will keep the constant voltage, that is around 1 volt. Okay. Now this 1 volt is nothing but the RMS voltage, and peak to peak voltage will be around 2 volt or more than 2 volt. Okay, it is around 3 volt. So I kept the voltage constant, and now I need to vary the frequency. Now you are not able to see anything here because the voltage is only 1 volt, and you can see for 1 volt 1, 2, 3, 3 into 1. So around 3 volt, that is the peak to peak voltage you are getting. So whatever voltage I am going to keep constant. So now this part is over, voltage measurement. I don't need the multimeter. What I have to do now, I have to measure the frequency. So to measure the frequency, we have already set it for the 1 kilohertz, or I can go a little bit lower. Now frequency decreases, lambda increases. E is equal to h nu, which is equal to hc by lambda. Lambda is inversely proportional. If I decrease the frequency, lambda has increased. Now what I have to do, I have to measure the frequency. So I have to measure horizontally. When I am measuring the horizontally, there is a horizontal scale. So I just bring it down and match the center to the reference scale. Now what I have to measure? I have to measure the divisions horizontally. So now it is 1, 2, 3, 4 divisions. Okay. So how many divisions I am getting? That is the 4 divisions. That is the distance between the two crest or two tubs, that is 1 lambda. That means I am measuring the 4 divisions and multiplying it by the time per division. So it is 0.5 millisecond. So I am multiplying it by 0.5 into 10 raised to minus 3 second. So you will get time, that is 4 into 0.5, 4 into 0.5, that means 4 divisions into 0.5 into 10 raised to minus 3, that is the time per division. So division will go and you will get the time, that is 2 second, that is 2 second, and frequency is nothing but 1 over a time. So 1 by 2, that is the, okay, it is not 2 second, it is 2 into 10 raised to minus 3 seconds. So 1 divided by 2, it is 0.5, and 10 raised to minus 3 in the denominator, it will go to numerator as a 10 raised to plus 3. So it will be 500 hertz. So you can see it is around 500 hertz. Now I am changing the frequency using this knob. So I will go to the next value. You can choose any value, doesn't matter. Okay, so I have chosen around 1 kilohertz. Now what you have to do? Again you have to measure the number of divisions. Now 2 divisions are there. Okay, 2 divisions. Time base I have not changed. So it is 0.5 millisecond. So 0.5 into 10 raised to minus 3. So multiply it. You will get time, that is 1 into 10 raised to minus 3 second. That is 1 millisecond. So this 10 raised to minus 3 will go up, and you will get 10 raised to 3, which is equal to 1000 hertz. That means 1 kilohertz. Now I am increasing the frequency. For that purpose, I am changing the range from 1 kilo to 10 kilo, and with the help of this knob, I am keeping some random frequency. Okay, now I have increased the frequency, lambda has decreased. So what you have to do, you have to change the time base. Okay, the frequency is now around 7 kilohertz, around 7 kilohertz. So we will see whether you are getting that value. Okay, now how many divisions are there? That is 1, 2, and around 2, it is between 2.6 and 2.8. So you can take the reading either 2.6 or 2.8, not 2.7, because least count is 0.2 division. So if I am taking it as a 2.8, fine. So how many divisions you get? 2.8, and time is now 50 microsecond, that is 50 into 10 raised to minus 6. So 2.6 into 50, okay, that is 130 into 10 raised to minus 6. So 1 divided by 130, which is equal to 0.769, 0.769 into 10 raised to plus 6, the 10 raised to minus 6, which is denominator, which will go up. So now if you shift this, just a moment, this is 1 to 2.6, 2.8 into 50 microsecond. So 50 into 2.8, 50 into 2.8, which is equal to, which is equal to 140 into 10 raised to minus 6, that is the time, 140 microsecond. So 1 divided by 140, which is equal to 7.14, 7.14 into 10 raised to minus 3, and now this 10 raised to minus 6 will go up, that is 10 raised to plus 6. So I am getting 7.14 kilohertz, 7.14 kilohertz. So it is around 7 kilohertz. So I will increase the frequency further. So it is around 10 kilohertz. Now we will try to measure number of divisions. This is 1 and 2 divisions. Okay, time base 50 microsecond, 50 into 10 raised to minus 6. So 50 into 2, that is 100 into 10 raised to minus 6, 100 millisecond, sorry, 100 microsecond. So 1 divided by 100, it will be 1 divided by 100, it will be 0.01. So 0.01 into 10 raised to plus 6. If I shifted these two decimal point by 2 digit, so 1 into 10 raised to minus 4 means 10 into 10 raised to minus 3, which is equal to 10 kilohertz. So you are getting 10 kilohertz. Further, I am going to increase the frequency, then I have to change the range. I will shift to the 100K and keep the frequency say around 50 kilohertz. Now here you can see the lambda has decreased, so I'm just changing the time base. Now measure the divisions. So it is around 2 divisions again, but time base is 10 microseconds. So 2 10 into 10 raised to minus 6. So it will become 20 into 10 raised to minus 6 second. So 1 divided by 20, which is equal to 0.05, 0.05 into 10 raised to minus 6, which is equal to 50 into 10 raised to plus 3, that is 50 kilohertz. So you can see it is around 50 kilohertz. So we have measured successfully the voltages and the frequency. For measurement of voltage, I kept the frequency 1 kilohertz constant, and then I change the voltage using the knob on the function generator and measure the vertical divisions, multiply by time volt per division. So I will get the voltage and then divide that voltage by 2 root 2, you will get the RMS voltage, which is displayed on the digital multimeter. For measurement of frequency, I keep the voltage, that is RMS voltage, around 1 volt. So peak to peak voltage will be around 3 volt. So I kept that constant, and then using this knob, I just varied the frequency. To measure the frequency, horizontally I measured the divisions. Multiply it by time per division. So I get the time. Then 1 over time is the frequency. So we calculate the frequency using the CRO. So we got the 5 readings for the frequency, 5 readings from the voltage, and we have already seen the measurement of phase shift. So these are the 3 activities you have to perform with the help of CRO.